6.0 day 2, we're going to multiply and divide monomials again and use some more properties of exponents. So what I want you to do first is this warm up really quick on your own, and then I will go over the answers. So the answers to your warm up are right here. And so the first one, you just had to add 4, 7, and 1 to get 12 and y to the third. On number 2, you have to subtract your exponents both times, and they ended up both being in the numerator. And number 3, they throw in a x to the 0, which remember is 1, so it pretty much just goes away. Your y's needed to be reduced, so it's y squared in the numerator, and your z's also did, z to the third in the numerator. Now, hopefully you copied down what is a monomial. Remember, it's a product of numbers and variables. Okay, that's just another way of saying it. So we're going to have a power of a power this time, okay? So basically what's happening is when you have an exponent with a power, you multiply those exponents. All right, so in other words, a to the m to the n would now become a to the mn. Okay, so we're multiplying here, not adding like we did yesterday. So for example, x to the second to the third becomes x to the sixth. Okay, difference between x squared times x to the third, that would be x to the sixth. Okay. Essentially what this is you're writing x squared 3 times, which is why it becomes x to the 6, because 2 plus 2 plus 2 is 6. So same thing on the next one. This would become y to the 12th, because 4 times 3 is 12. So let's talk about that a little deeper. All right. What's happening here is now we are going to have a parenthesis raised to a power. So we're going to take that power and we're going to distribute it to all of them. So that would be 3 to the third, x to the third, y squared to the third. Okay. Now, 3 to the third is not 9. It's not 3 times 3. It's 3 times 3 times 3. Okay, which gives you 27. Use your calculator if you need it. Then we have x to the third, and that would become y to the sixth. So when you have a power outside of the parentheses, you distribute, you have everything in the parentheses gets raised to that power, okay, including the numbers. This is always the part that people forget, okay? So for example, ab to the m becomes a to the m, b to the m. So some examples off to the right. Again, that 3 goes to both. So it's 2 to the third, not 2 times 3, it's 2 times 2 times 2, which would give me 8. 8 to the third. On the next one, we would square all of these. Okay, now be careful with squaring. Okay, when you square a negative, it does become a positive, right? Negative 3 times negative 3 is positive 9. Then this would be x squared and y to the 10th. Okay, if you type this in your calculator wrong, it's going to give you a negative 9. Remember, it needs to be negative 3 squared, not just typed in this way. Okay, this will give you a negative. This gives you the correct answer. For number 5, it says find the question mark. Okay, so for this one, if I know I'm going to multiply this by 2 and I need to get to 8, that means that it would be w to the 4th. So the same rules apply when you have a quotient. Okay, when you have a power outside of a parentheses, everything in parentheses gets raised to that power. Okay, so a to the m over b to the m. Okay, same thing, except now you just have a fraction as well. So the 7, the x, and the y get this power. 7 squared is 49, x squared, y to the 6th. Same thing on the next one. When you distribute the cube, okay, this does give me negative 64 because negative 4 times negative 4 times negative 4 gives me 16 times negative 4, which is a negative 64. Okay, so be careful with those negatives. Then we have a to the 21st over 5 to the 3rd, which is 125. Now, if you can reduce it, you should, but this one can't. What about the next one? What is the question mark, right? Well, if I need to go from 2 to 16, be careful. This is not 2 to the 8th. Remember, I need to raise it to a power, right? And specifically, that power would be 4. 2 times 2 times 2 times 2 is 16. 3 times 3 times 3 times 3 is 81. So let's get some examples with this. Okay, now you can go different routes for these. A big thing for me is I try to simplify the inside before I deal with this outside number. Okay, so let's focus on that inside, kind of like what we did yesterday. So we have negative 6 and 5. Nothing can happen there, right? But then I do have m to the 3rd over m to the negative 1/2. Remember, we do big minus small. So that really is like adding, right? Which gives me 3.5. Now you can keep it as 3.5, or you could rewrite it as 7 halves. I'm going to use 7 halves. Oh, not x. And it goes in the numerator because that's where the larger one is at. Now we have n squared over n to the 9th. That gives me n to the 7th, because 9 minus 2 is 7, goes where the 9 is at. So now I'm going to deal with using these squared. So negative 6 squared is 36. If you take 7 halves times 2 over 1, that would end up giving me 7. So that's m to the 7th. 5 squared is 25, and n to the 7th squared becomes n to the 14th. Next one. Again, I'm going to try to simplify the inside first. So y to the 3rd squared becomes y to the 6th. Okay, so now I'm going to keep simplifying, right? I have my y's, which means it's y to the 5th in the numerator. I also have negative 2 times negative 1, which gives me just positive 2. Now all I have to do is square all of them. So this becomes y to the 10th, 2 squared is 4, and x to the 8th. Now you are welcome to distribute before you simplify, but a lot of times that just makes it more difficult. So on this next one, I'm going to look at each individually first. So distribute the 4, we get x to the 20th over 2 to the 4th, which is 16, y to the 12th. And we're going to multiply what this one is. Distribute the squared. 4 squared is 16. This becomes x to the 4th, y to the 10th. Now because this is not a fraction, it's really over 1. And now we can just simplify, right? I have 16 and 16, so they're going to cancel. If we want to combine our x's, we would add those exponents and get 24. When dealing with the y's, we would do 12 minus 10, which gives me 2, and it goes in the denominator because that's where the larger one's at. Looking at number 12, I'm going to deal with the left side first, getting rid of the u to the 0 because that's 1. Distributing the cube. That gives me v to the 6th over w to the 6th. On the right side, we're going to distribute the squared even to the negative 1 on the outside, which makes it a positive 1. This becomes v to the 10th, w to the 4th, and we have a u to the 8th as well. So now again, we can just start simplifying, right? Think about it as one big fraction. We would add the v's, and we are subtracting the w's. So we would get w squared in the denominator because 6 minus 4 is 2, and we go where the larger one's at. Our last example here is a longer one. So again, I'm just going to focus on the inside, right? So if I focus on the 2 and the 3, nothing can happen, right? The x's becomes x in the numerator. The y's is 1y in the denominator. And the z's are 2 z's in the denominator. And now we're going to cube it. So I'm going to go ahead and finish this side off. Remember, we have to distribute it to all of the things in here. So 2 to the third is 8. Then we have x to the third. 3 to the third is 27. Y to the third. And z to the sixth. Now we're not done yet. We got to finish up this other side. X to the 0 is 1. The 4 and the 3 stay the same. X to the fourth can stay in the denominator. If you simplify the y's, you'd have y squared in the denominator. And for our z's, we'd have z squared in the numerator. Now we need to take our squared and distribute it to all. 4 squared is 16. Z to the fourth. 3 squared is 9. X to the eighth. Y to the fourth. Now it's time for one big fraction. So at this point, we can start dealing with our numbers, right? So we have 8 times 16, which is 128. We have 27 and 9, which is 243. Now, I didn't simplify anything because there is nothing to simplify, right? 8 and 27, 16 and 9, nothing that can cross cancel. So then we move on to our x's. If we have x to the third and x to the eighth, that's going to be x to the fifth in the denominator. We can also combine our y's, y to the third, y to the fourth, gives me y to the seventh in the denominator. And then we have z to the sixth and z to the fourth, which gives me z squared in the denominator. Now, if you're like me, that would bug me, so I'm going to move the 128 over. We don't have to.